All right, so let's go through the check and highlight some things that maybe you might still be confused on. And then I'll release you to start work on your classroom problems on big ideas, okay? So the M in front of the segment below refers to what? Measure, okay? And the difference between just this and the measure of AB, if I'm referring to segment AB, which is how I'd read this, then I'm talking about the physical segment from A to B. If I put the M in front of it, I want to know what is that measure. Okay, seems pretty self-explanatory, but it's still, some students find it confusing. So if you put an M in front, you just want a number. You want to know the measure of it. The actual AB means physically that segment AB. Okay? Question 2, an important idea that was mentioned in the video was that segment ST refers to a length, and ST without the bar refers to a segment. That's false. It's opposite. Okay, again, if I'm talking about AB, and this actually should have been that, but the segment AB, if I want the measure, another way I could write that is there without the bar. So this equals that. Okay, so my question was inverted. I said in the question that ST with the bar refers to the actual measure, the length. ST without refers to the actual segment. It's really reverse. Okay. Question 3, distance is sometimes, always, never positive. Always. Distance is always positive. I cannot say I'm walking a negative distance. Okay? I could say I'm walking a distance in this direction or this direction, but it's not a negative distance. It's always positive. Question 4, in which postulate is the sum of the partial lengths equal to the whole? Segment addition postulate. There were 2 postulates in this section, ruler postulate, segment addition postulate. This one's the segment addition postulate. Question 5, when finding the distances on a grid, if the segment is vertical, okay, let's stop right there. On a grid, if the segment is vertical up, down, or right, left? Up, down. So if I'm trying to find the distance of this segment on a grid and it's a vertical segment, think about this. Let's just look at the coordinate. 1, 2, 3, 4. And it's 1, 2, 3, 4, 5. And then this one is 4, -1. So what's going to tell me the distance? The x values or the y? The y. Okay, and the distance would be a total of 6 units on the y side. Okay. Again, ruler postulate should be pretty straightforward. Segment addition postulate, let me just do a problem here. If I was told that this segment was a total of 10 units, how could I write an equation to solve for x using the segment addition postulate?
4x minus 7 plus 2x.
Good. The segment addition postulate just says the smaller segments add up to the whole. Okay. Where this can get kind of confusing is if I had, I gotta think how I want to word this. Well, that's still not going to be that confusing. If I make this 3 and this x, and the whole thing was 2x plus 3, no. I wanted to find an unknown there. When you have to subtract, when you know the total distance, and you're going to have to subtract another distance to get the smaller. I mean, it works both ways. You add the two segments up to get the total, or if you know the total, you're going to subtract one of them to get the other. Okay, it should be pretty straightforward, but if you've got questions as you do the classroom problems, just let me know and I'll come over and help. Okay. All right, so go ahead. Let's see if we can get through classroom problems before you get out of here so that you don't have any homework. We have Challenge Day Monday, so you won't have class with me on Monday. So this assignment will actually be due Tuesday at midnight. I may not have made that in Canvas correct, but I'll try and get that done this weekend. So Tuesday at midnight. That way, if you've got any questions left over on this assignment, we can talk about them on Tuesday in class. Yep, 1.1, classroom problems and CK12 are due tonight. 1.2, classroom problems and CK12 are due Tuesday night. Okay? Should be a pretty easy weekend.